This week we're going to talk about dictionaries of functions and a func tool that you probably don't know about. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to show you a handy Python tip, which is putting functions into dictionaries. But while we do that, I also want to show you a func tool that I recently discovered and have been using quite a bit. And it's called the partial tool. So first we're going to go ahead and do a couple of imports. I'm going to import NumPy as MP. And then from functools, I'm going to import partial. What partial does is let us call a function with partial arguments, not all the arguments required by that function, and returns to us an object that is ready to accept the rest of the arguments, basically. Now, it's a little more complex than that if you want to go look at the docstring for it, but that's how we're going to be using it, and that's how I think of it. So first, let's make a function that we might want to have a dictionary of. I'm going to call mine moving average. And moving average is going to take the number of points we want in our moving average and the data. Remember, you always need to write a docstring. So this creates a moving average of n points wide. Okay, so how do we take a moving average? Well, we convolve a boxcar function, or a function that is 1 everywhere or for the number of points that we're going to take with our data, and then we divide that by the number of points wide that our average is, or our boxcar is. So what's that look like? That looks like returning mp.convolve of mp.ones, then we have to specify a size to ones, which is going to be n points, with our data. And then we divide the result by n points. Okay, so that's a little bit of signal processing you may or may not be familiar with, but that's a really quick and easy way to calculate a moving average. So let's see what this looks like. I'm going to create some data. I'm going to use mp random.random, and let's create 1,000 points of random data. I'm going to import matplotlib.pyplot as plt so we can make a plot. I'm going to call plot.plot on data. We'll label that as raw. And plot.plot on moving average of, well, let's say a 10-point moving average of our data, and label is going to be smoothed. And we'll put a legend on. Okay, so there we see our raw and smooth data. It looks like the smoother is doing what we would expect. If we've got random numbers in the interval 0 to 1, we would expect them to average to a half if we continue to increase the smoothing more and more. So at least from this standpoint, our moving average function looks like it's working, and we can go on and do a little bit more advanced things with it. Let's say I'm processing a lot of data, and instead of specifying how wide my filter is for a light or a medium or a harsh filter, I want to be able to easily interchange that. Well, I could do something like, say, light filter width is equal to 3, and then everywhere I want to apply that filter, I would call my moving average light filter width on my data, and that would work just fine. Notice I'm using tab completion to speed along my typing there. But I could also make a dictionary that contains functions as the value in the key value pair. So I could create a filters dictionary that has the keys light, medium, and let's go with harsh. Okay, so what would the value be? Well, we know it's going to be our moving average function. And we know that that takes some number of points. But what about our data? We don't want to pass that now. We don't know what it is. We could call light filter on any data. Well, this is where we can use partial. So from functools, I'm going to use my partial on moving average. And my first argument, positional argument, not a keyword argument here, is going to be 3. Okay, and then I can copy that for medium and harsh, and I can change my filter width. Let's go with 50. So now if I have filters light, I get a function. It's moving average with the first argument of 3. So I can call filters light and then my data, and that argument that I give is just appended to the list of positional arguments, and I get my data back, and you can see that it's the same values as I had up above. So now I can go ahead and make a plot if I wanted. Plot.plot data, plot.plot filters light on my data. And we're just going to copy that. And now we see that we have our raw data, our light filter, our medium filter, and our harsh filter, each with a lower noise band, if you will, and closer to an average of 0.5. So why is this a useful trick? Well, having dictionaries where the value in the key value pair is a function is a great way to call complicated functions or obscure functions in a more straightforward way. This reads better. When I read this, I know exactly what I'm doing. One of these could be called low pass or high pass or some other analysis filter that you want to use. This just reads nicer, which is more Pythonic. Using partial is a neat trick because you can partially specify the arguments to a function and leave the rest for later. So it's almost like having default arguments, which if you write the function, well, we could just give it. But what if you don't write the function? This is a nice way to modify functionality that's already out there in the Python ecosystem, which means you don't have to write more, which means there's less duplication of work. And there's nothing more Pythonic than that. I hope that you found this useful, and I'll see you on next week's MetPy Monday.